Hi, my name is Sean Ernst, and I'm here today to present work that my team and I have been doing on comparing public survey responses to absolute and relative probability forecasts of tornadoes in the context of the Storm Prediction Center's probabilistic forecasts in their convective outlook. First, of course, some background on that very product. The Storm Prediction Center Convective Outlook is a product that's been issued since 1955, though it was only tied to coverage probabilities, or the likelihood of a severe weather report occurring within 25 miles of a point, in 2003. The product initially encompassed three categorical tiers, slight, moderate, and high, and was expanded to 5 tiers in 2014, which are marginal, slight, enhanced, moderate, and high. These categories are underlied by the probabilities, but no changes to the probabilities occurred when the categories were expanded from 3 tiers to 5 tiers. Although forecasts in the convective outlook are generally very accurate, the communication of risk in this product is very challenging. It's very difficult to make sure or to develop a method for presenting the risk of a tornado later today to the general public. However, this time frame is incredibly important for communicating threats like tornadoes, hail, and high winds from thunderstorms, because it is an area where you can frame the public's mind for later occurring events, getting people ready for tornado watches and tornado warnings before those are issued so that they aren't having to scramble to prepare to respond to that issuance, that product, that warning. They can be ready ahead of time. So, how do we improve the risk communication in this product? Well, one potential solution was motivated by this severe weather outlook, which occurred on May 20th, 2019. As you can see, there's a high risk, or 5 out of 5 in the categories, outlook for southwest Oklahoma and northwest Texas. There's also a slight risk outlook, or level 2 out of 5 for New England. So, when we look at the tornado probabilities that underlie this outlook, we see that there's a 30% chance of a tornado within 25 miles of a point in southwest Oklahoma and northwest Texas, and a 2% chance of a tornado within 25 miles of a point up in New England. When we compare this to climatology, however, we see that at this time of year, the likelihood of a tornado occurring within 25 miles of a point on any given day is 1.2% in northwest Texas. When we compare this to the absolute probability, we see that the likelihood of a tornado on this day in that area is 25 times higher than average. Now let's do the same thing for New England. We see that at this time of year, there's a 0.1% chance of a tornado. When we compare that to that 2% outlook, we see that the likelihood of a tornado in New England is 20 times higher than average on this day. So it's actually kind of a comparable relative risk for these two areas, even though the absolute likelihood is very different. So the question is, does this relative risk information change user risk perceptions? There is some evidence in the literature to this being the case. When shown odds ratios, which are another way of saying relative risks, participants in this study by Leclerc and Jocelyn in 2012 were more likely to apply road salt in a road icing scenario when shown that odds ratio information versus when they were shown deterministic yes-no information or even absolute probability information. So it's possible that providing this relative risk information might change the way that people respond to severe weather events and might increase the rate at which they respond or prepare for a tornado, hail, or wind threat. So, some key questions we want to answer with this study. How do members of the public react to relative probability formats as compared to the currently used absolute probabilities? Second, what happens when we combine and show participants both formats at the same time? Does this change users' interpretation of risk? And do participants anchor to one format over another? Does their concern level when shown the combined format compare better to the absolute probabilities or to the relative probabilities? And finally, does their comprehension of these probability formats vary across numeracy, as has been seen in prior studies done looking at the SPC words and colors? Numeracy is an individual's ability to understand probabilities and likelihoods and perform mathematical equations, and we know for sure that it is closely related to individuals' abilities to interpret risk information. So, for data for this study, we used the 2021 Severe Weather and Society Survey, which is a representative sample of the U.S. public that included 1,550 respondents. It was fielded from June 9th to the 17th in 2021. You can see a map of where respondents were participated from across the U.S. here on this slide. So for an experimental design, we first asked participants in a question that came after another question in the survey. Now imagine that it is a different Saturday morning at 8 a.m. and you see this forecast. The 1,550 participants were then broken into 6 different groups so that each participant only saw one piece of information. The first group only saw that there was a 2% chance of tornadoes today. This is the current system, our sort of control group for this study. The next group saw only that tornadoes are 20 times more likely today than on an average day like today. This is the only relative likelihood group. A third group saw the combined format only, which is there is a 2% chance of tornadoes today, which means that tornadoes are 20 times more likely today than on an average day like today. All participants were then asked the same 2 questions, which we asked them to rate from 0 to 100 how concerned they were if they were to get this forecast, and how likely they were to change their plans for the day if they got this forecast. Note that there's only 3 groups here, and I said that there were 6 disparate groups for all those participants. We also presented participants with a higher risk level, which was 5%, 50 times more likely, and both of those combined. So, looking at the results, you can see we've broken down into 4 plots by whether or not participants were shown the lower 2% or 20 times risk level or the higher 5% or 50 times risk level, as well as their responses in their level of concern and their likelihood of response. When we compare the absolute risk, that's the 2% in this case, to the 20 times more likely, the relative risk case in the participants, we see that participants for the 20 times and 50 times more likely than normal, or the relative probability case, had a 33 and 32 point higher level of concern than those who were shown the absolute probability only. For the combined group, however, we see that those concern increases were lower, but still notable, with a 4.28 point concern increase for the combined format for the lower end risk, and an 11.9 point increase for the higher end risk. Notice that the increase in concern was higher for the higher level risk case, which is not something that you see across the absolute and relative probabilities when you compare the lower and higher risk cases. Those increases are the same. So there's a bit better differentiation for the participants when these 2 pieces of information are combined versus when they're shown only the absolute or only the relative risk. We see a very similar change across the different test groups in the likelihood of response, so we're not going to look at that anymore in this presentation. We're going to focus on the results for the participant concerns. When we break participants down by their numeracy, being low or high levels of numeracy, we see an interesting pattern. Namely, for the absolute risk case, low numeracy participants didn't have a large difference in their concern for the lower and higher risk groups, that being the blue and the red on this graph. So there's not a lot of differentiation between a 2% and a 5% risk for less numerate participants. However, for the high numeracy participants, there was a 9-point gap in concern between the lower and the higher risks, suggesting that more numerate participants were better able to discern the difference between the 2% and the 5% risk. This is what we expect to see, is more numerate participants are better able to understand risks and probabilities. When only shown the relative format, however, there was almost no difference between the perceived or the level of concern participants reported between the higher and lower risk groups for both the less and more numerate participants. You can see there was a 1.79 point increase in concern for the less numerate participants and a 0.68 point concern increase for the more numerate participants. This suggests that individuals aren't really discerning the differences in the risks when shown only relative risk information, or that only 20 times more likely or 50 times more likely than normal information. When combined, however, there was a large difference in concern for both the less numerate and more numerate participants, there being a 10-point increase in concern between the lower and higher risks for the less numerate participants and a 5.9-point increase for the more numerate participants, which suggests that this combined format is able to help participants better understand the difference between these two risk groups. So in conclusion, we found that absolute risks, when shown alone to participants, lead to a lower level of concern response, while the relative risks, when shown only to participants, result in a higher level of concern and likelihood of response. The combined format does appear to anchor or be most similar in level of concern and likelihood of response to the absolute format by itself, but there's better differentiation across the different risk levels when these two formats are combined, which is a really important thing to understand. Numeracy also does appear to play a role, with the combined format showing better differentiation across risk levels for less numerate participants than the absolute or relative risk formats, again suggesting this combined format is helping participants better understand the risk that is presented to them. Overall, the impacts of relative risk information are modest, except for when the relative risk format is by itself. There's a lot more concern and likelihood of response when participants were only shown the relative risk information. Some future work that we have planned for this investigation, we want to build a daily relative risk database from SPC storm report data so we can see how relative risks change across a given year across different regions of the US. So we have a bit of a baseline for what we expect to see in relative risks. We also want to test user responses to climatology-based relative risks in the Outlook format. Instead of just presenting words and sentences, we want to show them an image that they can work with. Finally, we want to further investigate higher-end relative and absolute risk pairings. We're wondering if there's a potential for diminishing returns on relative likelihoods for concern and likelihood of response. For example, is a participant's response to seeing that they are 100 times more likely than normal to experience a tornado different from their response when they're told they're 1,000 times more likely than normal? These are things that we'd like to know if this is to ever become an operational product. Otherwise, thank you so much for listening to my talk, and I hope you enjoyed it.